Hello and welcome to yet another lecture on basic electrical engineering. Myself Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Degree Engineering College, Electrical Engineering Department. So today we will discuss about the source transformation and the Thevenin's theorem. So in order to obtain the source transformation first and so the source transformation we will do first, then followed by the Thevenin's theorem. So till now we have learned about the KCL, KVL, nodal analysis, loop analysis, mesh analysis. Now today we will do the source transformation. So in order to do the source transformation means we are converting the current source to the voltage source, equivalent voltage source, and the equivalent voltage source to current source. So this is known to us as a source transformation. Means we are converting a current source to an equivalent voltage source and a voltage source to an equivalent current source. This is generally known to us as source transformation. How we will approach to the process of source transformation. So first, in order to do this, let us take a circuit having a voltage source and a resistance. So say this is a 10 volt and this is a 5 ohm resistance. So how much amount of current is flowing through the circuit? The current that is flowing through the circuit I using the formula of ohms equal to V means V minus V0, V minus 0 that is the voltage difference by R. So here V is 10 minus 0 the voltage difference by 5. So the current is 2 ampere that is flowing through the circuit. The current that is flowing through the circuit is 2 ampere. In order to transfer this voltage source to an equivalent current source, in order to transfer this voltage source to an equivalent current source, I am taking a current source of 2 ampere here. I am taking a current source of 2 ampere. This is the current source of 2 ampere and connecting the same resistance that is 5 ohm resistance in parallel with the current source. Connecting the same resistance in parallel with the current source, that is 5 ohm. So now what is the voltage across that point? So this is a AB point. So what is the voltage across AB point? If I calculate the voltage that is V of AB, that is nothing but I into R. That is I according to the Ohm's law into R. So it will be 2 into 5, that is the voltage is 10 volt. So in order to convert that current source of 2 ampere and 5 ohm resistance to an equivalent voltage source, we have taken a 10 voltage source means this 10 volt, and just we have to connect the 5 ohm resistance in series with the 10 volt to converting the current source to a voltage source. Means this is called the source transformation. First, we converting a voltage source to equivalent current source, means we have to find the current and we have to connect the resistance in parallel with the current source. In order to find the voltage source of equivalent current source, we have to find the voltage across this resistance. That is, here it is the V of AB equal to 10 volt, and we have to connect the resistance, that is 5 ohm, in series with the voltage source. So this is generally known as source transformation. Now we will do the Thevenin's theorem. So what is the statement of the Thevenin's theorem? Thevenin's theorem states that according to Thevenin's theorem, the current flowing through a load resistance RL connected across any two terminals A and B of a linear bilateral network is given by VOC by Ri plus Rl, where VOC is the open circuit voltage, that is the voltage across the terminal AB. It is given that the voltage across the terminal AB when RL is removed, and Ri is the internal resistance of the network as viewed back into the open circuited network from the terminals AB, deactivating all the independent sources. What are the following limitations of these theorems are given that the Thevenin's theorem cannot be applied to a network which contains nonlinear impedances. This theorem cannot be calculated the power consumed internally in the circuit or the efficiency of the circuit. So in order to obtain the Thevenin's theorem can be explained with the help of the following examples that we will see that. So first what we have to do, we have to, this is called the load resistance RL. So first we have to find the VOH or VTH. So how we can able to find the VOH or VTH? First of all, we have to open circuit that thing. This is the open circuit, and then we have to find the VO or the open circuit voltage after removing that RL terminal. This is called the VOH, VTH or VOC, the Thevenin's voltage. The second part is that we have to find, we have to look all the independent sources. If there is a current source, it will be open circuited. If there is a voltage source, it will be short circuited, and we have to view from the terminal AB in order to find the RTH. That is RTH. Our third step is that VOH that we have or the VOC that we have get, we have to connected the RTH in series of the with the VTH. Followed by that the RL at which the voltage have to measure, we have to connect it in series with the RTH in order to find the current that is flowing through the load resistance RL. This is the equation in order to find the Thevenin's theorem. Now let us take an example in order to obtain the step by step, so that we can able to find the different steps, so that we can able to understand it. Let us take an example. In order to find the all the states of Thevenin's theorem. So the all the statement that is given that we have to obtain step by step Thevenin's theorem. so that we can easily able to understand the each step and the statement that is given in the theorem. So let us take a circuit in order to find the Thevenin's theorem. So this is say 10 volt, this is 2 ohm, this is 3 ohm, and this is 5 ohm. We have to find the current that is flowing, the current, say the I, that is flowing through the circuit, and this is generally known as RL, the load resistance, and this terminal is known as say AB. So we have to find the current I that is passing through the load resistance RL. We have to find the value of I of RL using Thevenin's theorem. Means the current that is passing through the terminal AB or the load resistance we have to find using the help of Thevenin's theorem. Okay, so in order to find the Thevenin's theorem, first step we will go for the step 1. Step 1 that is suggested that step 1 that is suggested we have to find the VTH, that is the Thevenin voltage, or that is known as VOC, that is the open circuited voltage across the terminal AB. Across the terminal AB, we have to find the VTH or VOC. So how we will find? Means we have to open that particular part. So just draw that. Means we have to first we have to open the RL part. RL part means the part which across we have to determine the VTH or VAB same or the VOC. VTH stands for Thevenin voltage. This is called the FV. This is the 10 volt. This is 2 ohms. And this is 3 ohm. We have open circuited the RL part. This is the part at which we have to calculate the current. So we have to find this voltage is generally known as what we can say VTH or VOC. Same. VTH or VOC. This thing we have to find VTH or VOC, or say we can write the VFAB. Same. VFAB means the voltage across the terminal AB. So what is the value? This is open circuit, so there is no current is flowing through the circuit. So from the conception of the open circuit, it is found that if there is no current in the circuit, the total voltage will be dropped across the terminal AB. So VTH or VOC or VAB is 10 volt. So this is taken as a 10 volt. This is our first step. We have to find the VTH or VOC, and it is found as 10 volt. Means the voltage across the, means we have open circuited the load resistance RL part. First open that. First step is to open the RL part that we have done, and we have to measure the voltage. Open the RL part. First step. and then means the resistance at which the current flow have to be measured with the help of Thevenin. Followed by we have to calculate the VTH. There is the I is for the particular side, the value of I is 0 means no current is flowing, it's open circuit. So the voltage across the terminal will be same, means the voltage across the terminal, say CD, will be same across the terminal of the voltage AB, and this is known as open circuit voltage or VTH. Okay, so now the step 2 is we have to find, we have done the step 1. So step 2 is we have to find the R equivalent. We have to find the R equivalent of the circuit. So how you will approach to find the R equivalent of the circuit? It will be our second step. So VTH is 10 volt is known to us. So now we are going with the step number 2. Step number 2 suggests that we have to find the R equivalent. We have to find the R equivalent. So what is the process to find the R equivalent? If all the sources that is there is clearly written that we have done the voltage across the terminal AB where RL is removed, and RL is the internal resistance network viewed back into the open circuit network from the terminals AB, deactivating all the independent sources. So if there is a voltage source is there, if there is voltage source, if there is voltage source, it will be short circuited. All the independent source will be removed, and if it from the circuit, and if it is current source, then it will be open circuited. This is the rules to nullify all the independent sources are there in the circuit. If it is voltage source, then it is short circuited. If it is current source, then it is open circuited. Now there is a voltage source, so it will be short circuited. How? It is there's 10 volt is now. I have short circuited that one. The 10 volt is short circuited. Okay, so this 10 volt is short circuited. This part, voltage source. So this is our A and B point, and we have to find the, this is our A and B point. This is 2 ohms. This is 3 ohms. So we have to find the R equivalent. How? In order to find the R equivalent from the terminal, we just put our I. We just put our I on that particular, means we have to view from here. We are putting our I. In other words, we can consider that, so that we can easily understand that, just consider that particular thing, that there is a voltage source is there. Just consider it that there is a voltage source is there. Okay. If there is a voltage source is there, means current is flowing from the positive side. This is a positive. This is the positive side. Means we have to view from there the terminal AB. So what is that means? The view from the terminal means we are just considering a voltage source. Just imagine this voltage source is not in this circuit. We just imagine there is a voltage source. This is a positive, this is a negative. Means current will start to flow from the positive and it will rotate back to the negative side. So it is seen that same amount of current is flowing through the 3 ohm and 2 ohm circuit. If we view from the terminal AB, it means that this 3 and the 2 ohm are connected in series. So the R equivalent is the summation of 2 ohm plus 3 ohm viewing from the terminal AB, and it is given as 5 ohms. So what is the value of R equivalent? It is 5 ohm. The value of R equivalent. Viewing from the terminal AB means that we have to ima- we have to think about imaginary voltage source there, so that you can easily able to understand. And the current is starting from the positive side, means that side, and it will rotate back to the negative side. This part means the ground side. So means if I consider a voltage source there, or view from the, we have to view from the terminal AB. So it is seen that the same amount of current is flowing to the 3 ohm and the 2 ohm, and that is they are connected in the series. So total R equivalent is 5 ohm. Now we are moving towards the step number 3. Our step number 3 is written that VTH and the R equivalent, that the VTH and the R equivalent will be connected. Step number 3 is written that VTH and the R equivalent will be connected in series. That VTH, that is the VTH or the VOC, that is known to us, VTH or the VAC, that is 10 volt, or VOC or VAB, same, it is 10, that is 10 volt. And the resistance, that is R equivalent, will be connected in series with the VTH, that is R equivalent, that is R equivalent, that we have found, that is called the 5 ohm, will be connected in series with the VTH, followed by the resistance at which we have to measure the current, that is the RL, that is the 5 ohm. The previous RL, that is the 5 ohm, is given in the circuit, that is the 5 ohm, that the RL. It will be connected in series with the R equivalent. So this is the RL that was omitted previously, or make it open circuited. The 5 ohm, it will be connected in series with the R equivalent. So what is the step 3? There is the VTH, the voltage, the open circuit voltage, or the Thevenin voltage, and the R equivalent means the R equivalent, that the 5 ohm, both will be connected in series, means the RTH will be connected in series, R equivalent will be connected in series with the VTH, or say RTH, same, R equivalent or the RTH, it will be same, the Thevenin equivalent resistance, RTH or R equivalent will be same, and the resistance at which we have to measure the current, that is the 5 ohm that we have open circuited at the step 1, will be connected in series with the R equivalent. So now we are approaching to the step number 4. Step number 4 is to find the current through the circuit, or current through the RL. I of RL means current through the 5 ohm resistance. So what is I of RL? It is the voltage 10 volt followed by the summation of the total resistance, that is 5 plus 5, means we can write till we VTH in that manner, or V of OC followed by RTH or R equivalent plus R of L, the load resistance. So what is the current through the R of L? That will be that VTH is the 10 volt followed by RTH here 5 ohm, RL is also 5 ohm here, so it will be 10 by 10, that is 1 ampere. So what is the value of I of RL? I of RL will be, using the conception of the Thevenin's theorem, I of RL is 1 ampere. That is the answer using the conception of, this is our fourth step. Fourth step is we have to take the VTH in series, and then the I of RL is the VTH divided by RTH by RL, and here RTH and RL both are 5 ohm in this case, so 10 by 5 plus 5 equal to 10 by 10 equal to 1 ampere is the RL, that is RL, I of RL, that is the I of RL. So this is the way of Thevenin do in order to find the current I of RL with the help of the Thevenin's theorem. Now how we will cross check that our answer is right. So let us take this simple circuit. So what is the current? So this current is say I of RL. So what is the current? All same current is routed to 2 ohm, 3 ohm and 5 ohm resistance. So the I of RL will be, how we can check that this answer is right? It is the voltage, same conception, the total voltage by the total resistance. So the total voltage is 10 volt and total resistance is 2 plus 3 plus 5. Same amount of current is flowing, that is 10 by 10. So it is 1 ampere. So we can easily cross check it that both the answers are right and both the answers are 1 ampere. This is 1 ampere, and with the help of Thevenin's theorem that what we have get is the 1 ampere. So both the answers are right. So this is the way how you can approach to a Thevenin's problem with the help of Thevenin's theorem. So today we have learned about the source transformation, means a equivalent voltage source is converted to equivalent current source, and along with the conception of Thevenin's theorem. How we can approach to a problem, and then how we can verify that the answer is correct with the help of Thevenin's theorem, which means how we can approach to a solution of a problem with the help of Thevenin's theorem. Thank you.